Hello everyone. Welcome to our yet another special class academy webinar celebrating the Global Energy Independence Day. Renewable energy in construction is revolutionizing the way we build to create more sustainable and energy efficient structures. This shift not only reduces the environmental impact of buildings but also drives us towards a future of greater energy independence and resilience. Global Energy Independence Day, observed on 10th of July, reminds us of the importance of reducing reliance on non-renewable resources and moving towards cleaner energy systems. This interesting session will explore the crucial role of architecture playing in advancing energy independence, highlighting cutting-edge approaches to reducing energy consumption and integrating renewable energy resources. Get ready for an engaging discussion filled with practical insights and inspiring case studies that demonstrate how sustainable architectural practices are key to achieving global energy independence. Today, we are honored to have an esteemed architect whose innovative work in sustainable design and energy efficient buildings is paving the way towards a greener future. We have with us architect Faiza Khan, founding partner, Field Architects, based out of Ahmedabad. Faiza Khan earned her B.Arch degree from Academy of Architecture, Mumbai, and pursued her M.Arch from Barcelona Institute of Architecture in 2011. She has worked with Malik Architecture, Siri Architects, Stantec, and Studio Mumbai. Since their inception, Field Architects have actively collaborated on adaptive reuse and conservation projects of various scales with Archaea Association India, a non-profit organization working to safeguard the outstanding but endangered cultural heritage in the Himalayas. They have coordinated and taught the Passive Solar and Earth Building 2-year course and worked on various passive solar buildings with Sekmol and Hial in Ladakh. Architect Faiza has also curated the Sun and Earth Festival of Ladakh in 2017, which had multiple hands-on workshops exploring earth building techniques and design principles for climate-responsive buildings. Field architects have executed projects across many sectors and scales, and their recent projects in Ladakh employ passive solar heated design. While practicing contemporary vernacular architecture, they explore the adaptive potentials of local materials and aesthetics of the Trans Himalayas. Joining her is Ms. Kaarinka, who is a design consultant, Infinity for Saint-Gobain India Pvt Ltd. Ms. Kaarinka is a civil engineering graduate from Coimbatore Institute of Technology. She has taken the role of design where she helps in providing solutions for facade glass from a safety, sustainability, and aesthetic point of view. She provides design and technical support for commercial and residential projects. She does analysis and design documentation for glass section involving building physical concepts. Welcome, Architect Faiza and Ms. Kaarinka. We are delighted to have you here with us today, and we are looking forward to sharing your wealth of knowledge and expertise to our webinar series. So let's dive into this topic of today's discussion, harnessing energy efficiency, the role of double glazed and solar controlled glass in modern architecture. Let's begin with you, Architect Faiza. So thank you so much for joining us with the session today. Before delving into today's topic, let's reflect on your path as an architect. We would love to hear about you and your journey as an architect till date.
Hi, everybody. It is my pleasure to be here. And starting with your question, so the journey has been long. Like I graduated from Barcelona. Like my master's I completed in 2011. Then working with different offices and all. At a certain point, yes, every architect wants to have their own practice, but it's not merely like you decide to have a practice and you open a shop and you can just start working. There has to be certain kind of aspiration, inspiration, or motivation. So me and my partner Suril, we decided to like travel across India, and that's how. So one of the destinations was either Assam or Ladakh. We chose Ladakh first, and so we were here just meeting some locals and all, and they just said like there is this institute called 𝐷𝐸𝐚, and they employ architects. Why don't you guys just go there and see their work? And we were in a thing like, we'll be in Ladakh for 3 months, 4 months. We'll just try the winter, and then we'll move on to Assam or something. But there we went and we met 𝐵𝐚𝐚 Wangchuk, and then we didn't know that time who 𝐵𝐚𝐚 Wangchuk was, and he was like, we wanted architects to build or design certain buildings and also teach a solar and earth building course, but the commitment was 2 years. So we just happened to look at each other and we're like, okay, let's do it. I mean, what's wrong?
Yes.
And that's how it started. And so it was very organic that we started working at 𝐷𝐸𝐚, teaching students, traveling across Ladakh, knowing everything at a very grassroots level. And then slowly, Kapil Gupta, who's the co-founder of CD Architects, he had visited Ladakh and he introduced us to one of our first clients, that is Ladakh Sarai. And then that's how we got a first project, and then second project, and slowly and steadily, now it's been 9 years in Ladakh. Yeah.
That's amazing.
Yeah.
That's
So
good.
it wasn't planned, but it was learning and giving on the way, and let the things take its course. That is
Great. Got that. So, building in the mountains, specifically in the Ladakh region, where the terrains pose unique challenges, is impressive, and you've been a pioneer in the field of mountain architecture. What inspired you to specialize in this area and pursue it as a career?
so. It wasn't a conscious decision. It was like coming here and like just being open to learning everything and unlearning what we have been taught in architecture school. So observing, sharing with the locals or the artisans here was one of the most important parts, and especially the learnings at 𝐷𝐸𝐚, where we learned about passive solar building. So, and with our background of architecture like planning, designing, detailing, it really helped to come together everything over here.
So, let's move into today's topic.
Mhm.
Energy efficiency as a concept is the need of the hour in today's construction world. Can you start by explaining the importance of energy efficiency in modern building designs? You could also name some important aspects of using them in building design.
Okay, like the energy efficient buildings, when we talk about practicing sustainable buildings in eco-sensitive areas like Himalayas, the whole idea of energy conscious building is very different. Like the idea is to source materials locally,
Right.
to avoid as much as possible industrial products which have so much of carbon footprint because they are not from here, and you have to get in trucks. And especially in a place like Ladakh, like because of the strong UV, the cold desert region, the dry weather, the extreme cold, cement doesn't perform even half as much as it performs in the plains. So that is one of the main problems. And generally, earthen buildings are much more insulative. They have a better thermal lag, and so that ways.
That way.
Uh,
Yeah, sorry, go ahead.
So in materials, I would say, so it's not that you don't have to use cement or something, but it's like you have to use it sensitively where it is actually required. Because right now the industry pushes so much. Like earlier when we used to practice here, like we could easily source the local materials. But now there is certain bylaws of using local materials, and it makes people more distant
Got
from
it.
their own vernacular knowledge.
Got it.
So
And
yeah.
do you want to focus something on, designing with respect to the orientation of the building or how the lay of the land is, and how do you do it in Ladakh terrains, etc.?
Mhm. So in Ladakh, like, so we are building a lot of homes and we try to educate the client for passive solar heated homes. In that, you have to have the solar south, which is around 32 degrees to, yeah. So solar south is very important. And like, then your east, west and north facade to be completely insulative. And using earthen materials, like you can use rammed earth, you can use Adobe with insulation. Yeah.
Got it.
And terrain, it depends. Sometimes you have a flat land, sometimes you have a or sloping land. So it depends. Most of
Depends
our
on.
structures, yeah, most of our structures are load bearing.
Oh, that's great.
Yeah.
Okay. Now on to you, Miss Kaarinka. From a technical point of view, how do you think glass plays an important role in harnessing the overall energy efficiency of building systems? And what key factors do you prioritize for optimization?
Thank you, Shruti. It was great hearing from you, Ms. Faiza, on your work in Ladakh. So, moving on to your question on glass specifically. See, glass as a material enables people to connect with their external environment. At the same time, it offers the ability to control the amount of light and heat that can enter a certain space. So, if you see the key parameters of glass that can play a part in your specific question of harnessing the overall energy efficiency of building, I would highlight three parameters. First is VLT, visual light transmission, which is the percentage of visible light getting transmitted through glass. Secondly, SHGC, which is solar heat gain coefficient, that is the direct heat gain due to solar radiation. And thirdly is the U value or the thermal transmittance of glass, which is the amount of heat transferred due to temperature difference for a square meter of glass. So if you see from Saint-Gobain's point of view, Saint-Gobain's Infinity range, which is our exterior glass products, offers wide range of options for the parameters I mentioned earlier, like VLT, SHGC, and U value. Infinity range offers products of optimum VLT with minimum glare and less direct and indirect heat gain, thereby minimizing your cooling load as well as enhancing energy efficiency of the building.
Okay, that's good to hear about the products and that's what Saint-Gobain offers. Great. Now back to you again, Faiza. A little deep, diving a little deeper regarding materials that contribute to energy efficiency in building construction. What are some materials you use in your practice that have a proven track record of enhancing energy systems?
So I think glass is one of the very important materials because we for passive solar buildings we have either direct gain or a trombe wall system. So with DGUs, so glass is a very important system for our capturing the solar radiation in the buildings. And in with that, all the locally sourced materials, earthen materials, we use repurposed army mattresses for insulation, or sometimes we have styrofoams, polyesterins that ways.
Great. Do you want to give a two-liner about the trombe wall system that you would like to share with the audience, because we have a young audience that will listen to this webinar?
Okay.
It would be a great takeaway.
So I think trombe wall I can explain when I'm explaining the project also, because I think with the diagram it will be much better. But telling in short, it consists of two wall systems, which has a double glazing in the front, then a around 20 centimeters cavity, and then you have a thermal mass wall.
Okay.
So basically your radiation is captured through convection and conduction. That ways. So it's so the air in the cavity heats up, and that's when you open the windows and then it enters the room and stuff. That ways.
Great. That's
awesome. So I'll explain more in detail once we are sharing the project and all. But meanwhile, like here we use for glass we use 5 mm DGUs, like 5 plus 5
DGUs. Okay.
Yeah, and sometimes recently we have started having DGUs with argon or proper aluminium strips. But here we would just make locally sourced, like we'll have a mattress covering it, or we'll have just silicone, so that ways.
That's a good balance of, materials that.
Yeah, because in Ladakh, sourcing materials is very difficult.
Right.
So how much we can get locally and easier, it's better. Yeah, so most of our projects are concentrated here. That's why.
Now moving to the next question. Ms. Kaarinka, since we spoke about materials and technologies, from your experience, how do a double glazed window system contribute to energy efficiency in a building?
Okay, so just to give an intro on DGU, I would like to state it as an insulating glazing unit, IGU. It basically consists of two or more glasses separated by a vacuum, or it could be a gas field that reduces your heat transfer.
Yeah.
Insulated glazing unit, when combine with high performance coating, it minimizes both of your direct as well as your indirect heat gain through the facade. And this advanced coating that is done on to glass restricts the entry of heat into the building. At the same time, it allows natural daylight to come inside. And by using this IGUs, the U value of the glass can be significantly reduced. And U value plays a significant role for both your warm and cold climates.
Yeah.
For example, in hot climates, both SHGC and U value play an important role. In fact, both SHGC and U value should be lesser, so the heat ingress is lesser. And if you take for colder regions, the emphasis is of U value is higher, so that the warmth contained within the living space does not transfer outside. Yeah.
Great. That's a great take on the values that you gave us today. Awesome. Now back to Architect Faiza. Your portfolio consists of a wide variety of projects in different terrains, especially in the hills. In such projects, how does your approach to selecting and incorporating glass materials enhance energy efficiency and comfort within the buildings?
Okay. Selection of glass, you mean? So right now, because in hills like where we are, we really don't get IGUs. And if we have to order, then the cost is a certain high, and the clients are not really open for it. But we tend to have, like, if it's a larger glazing, then it's more like using toughened glass or laminated sandwich glasses. And otherwise, it's just normal 5 mm float glass is what we use.
Okay. And have you guys experimented with glass in the interiors or something, or it's
Interiors, not really. Like, it's mostly walls, like civil work. Yeah. But externally, especially on the south side, we use a lot of glass, but whatever is available here. Yeah.
Got that. Now, moving on to Ms. Kaarinka, can you discuss Saint-Gobain's latest innovations or strategies for harnessing energy efficiency in building materials and solutions?
Sure. So we have our research facility, which is Saint-Gobain Research Facility in Chennai at IIT Madras Research Parks, where the focus is more on developing products and solutions specifically for the Indian climatic conditions. And one more thing I would like to highlight is 1 in 4 products sold today by Saint-Gobain was developed in the last 5 years, which means we are continuously developing products. And through extensive research at SGRI, we have been launching different range of products that meets the demands of customers with respect to performance as well as the shade. The primary focus is to improve the selectivity of the coatings, which is the ratio of light to heat. To give a context, the better the selectivity, more light will be allowed, and at the same time, more heat will also be cut. For example, we have a double silver coated glass SKN 152 that has a light transmission VLT of around 49% and SHGC of 0.27, which is offering a high selectivity of 1.8 in a double silver product. And one another latest advancement from Saint-Gobain I would like to highlight is 𝐿𝐴 glass, 𝐿𝐴 India, which is India's first low carbon glass, which will significantly decrease the embodied carbon of the building. 𝐿𝐴 India glass could be used in buildings that are transitioning towards net zero energy buildings.
Net zero energy efficiency.
Yes.
Great. That's really nice to hear.
Yeah.
Again, back to Architect Faiza. From your expertise of so many years in the field, what are some challenges or limitations that architects face while implementing energy efficiency systems like this?
I think it's going against the industrial push where you have materials which are so readily available, and the clients prefer, like, let's do it very fast, and they don't oversee the longer future, or the better maintenance cost, or better advantages of the products, or the construction technology or the methods. So educating the clients in that aspect and telling them that this is better for your building, that is one of the bigger challenges. Yeah.
Okay.
And in Ladakh, especially, there is a logistics getting material. So you have to plan really beforehand to source certain products or something which is not readily available. Yeah.
This is another limitation that you would
Yeah.
for architects practicing there.
Yeah, because you're like, it's closed during winter months, like for 4 to 5 months. And then when the road starts, that's when you start getting your materials, that is.
I got that. Okay, great. To end with, it would be lovely for you, Miss Kaarinka, to let us know some tips and tricks that we could keep in mind while designing a facade with glass with respect to safety and sustainability aspects.
Sure. Yeah. One way is to align the building orientation by keeping in mind the sun path in order to eliminate heat ingress through the long side of the facade. Secondly, choosing high performance glass, which will maximize your natural daylighting inside your space, at the same time minimizing excessive heat gain and enhance the energy efficiency of the building. Thirdly, choosing the performance parameters of the glass according to the window to wall ratio of the building. Higher the window to wall ratio, we could go for a glass with lesser VLT in case there is no shading. In fact, there is no one size fits all. It depends on multiple factors like design, orientation, and window to wall ratio, etc. With respect to sustainability, while selecting glass, we should keep in mind the triple bottom line of sustainability, which is people, planet, and profit. From the people perspective, occupant comfort and safety is primary concern. Hence, usage of high performance glasses will bring acoustic, thermal, visual comfort and improves the well-being of the occupants. For the safety of people, tempered and laminated glasses could be preferred, since tempered and laminated glasses are considered as safety glasses as per the National Building Code as well. The thickness of the glass for the building are to be decided as per the wind load and the location of the building and other terrain conditions, etc. From the planet perspective, we could choose eco-labeled, EPD verified and locally sourced materials. And from the profit perspective, glasses which gives better ROI, return on investment, could be chosen.
That's great. Thank you so much, Architect Faiza and Ms. Kaarinka, for sharing those insights. Before we wrap up the webinar for today, we were hoping that Architect Faiza, if you could quickly walk us through your work related to promoting energy conservation through architecture and show us some glimpses of your work. You may share your screen and present now. Over to you.
Yeah. So, hi. So, I'm going to share this project which we completed 2 years back, which is the Thinlas residence. And it's located in Sabuthang. It's about 15 to 20 kilometers from Leh town. So Sabuthang is an area which is basically, you have a lot of people from different villages in Ladakh who want to come to Leh city for tourism work, or generally it's a city, right? So there's an urban growth. And the Thang areas are one which doesn't have really water source or greenery. But because it's land is available, they buy the plots and they start making their homes. So it is an area where you see very rapid and erratic construction. And so we have, so our client is had bought a plot there. And this Thinlas residence is basically very for a very sweet family of husband, wife, and a child. And so what you see is like it has a completely rock outcrops all around. Right now, it's all you won't see the open space because it's just been built around with so many houses. But anyways, so the ground floor is rammed earth, about 60 centimeters thick walls with insulation of styrofoam. And the upper part, which you see plastered, is adobe walls, again with insulation, but of army repurposed mattresses, which I'll talk in detail.
Yes.
And so this part, what you see is the south facade, where we have the maximum amount of glazing. This is the west part, where we have the bedroom. And then we have a water tank room with a water tank within the building. The south part, where it has a trombone systems, and it has an attached greenhouse system, which is heat gain through your just the conduction of the convection of the hot air. So this is further, like you enter from here. This is your main door, and this is an attached greenhouse. This is during construction. And the upper rooms are the trombe wall. So trombe wall is basically also good for bedrooms or spaces where you're going to use in the night, because the thermal mass stores heat and slowly in the night it radiates. So it's very comfortable for night use. And the greenhouse is basically in the winters, it gets very dry, the weather. So to have some greens, just with the attached greenhouse, it also maintains a certain amount of humidity and also for the heat gain. So this is your living room, kitchen, which has the attached greenhouse. This is the living kitchen and the whole space, which has the greenhouse in the front. So it is the design is based on the local technique of kabzi, which is traditional Ladakhi chansa having 4 wooden columns. And the space, all the activities just revolves around this room. So we had a modern concept with an open kitchen having the 4 columns, and then we have the living area on this side. So it's a through and through space. This is the bedroom. This is your west window, and this is basically what I was talking. The outside is the outside glazing. What you're seeing, it's a DGU, which has double glazing. The inside is single, and in between the two, there's a 20 centimeters gap. And what this white wall you see on the outside is painted black, and it is actually a thermal mass which stores the heat.
Oh, okay.
These ones.
Got that. Yes.
Yeah. Talking something about construction, like energy efficiency in that. So we have dry stone foundations, and we have a RCC tie which runs, and it has a wooden shuttering which we left as it is to so that there's no thermal leakage.
Got it.
Yeah. So the wooden it just breaks the whole thermal leakage which happens through the foundations. And then we have this is the rammed earth walls. It's about 60 centimeter thick with the styrofoams sandwiched in between. So this is for the east, north, and west. On the south side, because we want the solar gain, we have avoided using the insulation.
Okay. Nice.
These are the rammed earth walls. This is the living room space, which I had shown the photo earlier of installation of the wooden beam and then the columns and all. Okay. And then when you go up, again, we have wooden rafters for the roof. Then again, we have a roof tie, because Ladakh falls under seismic zone 4.
Yes.
And we need to have some measures for earthquake resistant structures. And then we have for insulation here, we have used straw and clay and wood shavings. So wood shavings with whatever the furniture or the carpentry work happening, the wood shaving is mixed with clay, and that is used as insulation. So it's about 6 inches to 7 inches thick layering.
Great. Okay.
And then on the upper walls where we have the adobe structure, these are basically Ladakh is in the border area, so we have a lot of army mattresses which are second hand, and it's given for a very cheap price, because it's it's second hand, and we can repurpose it. So we have used this as insulation, to just control the budget and not using thermocol or styrofoams that ways.
That's a very different and a unique take, catering to the local.
Yeah.
Got it.
So trying to be energy sensitive with local materials,
Yes.
whatever is available.
Got it.
Then this is your trombe wall and the greenhouse facade. So upper wall, which you see, if I zoom in, so outside glazing is the DGU. Then the cement is a very good material for thermal mass because it absorbs heat fast and then it slowly radiates, and especially when it's painted black in color. So this is during construction. So that's, you have DGU outside, you have a thermal mass wall, and inside again there is a door which when open it allows for the convection to happen. So this is the whole science of the whole facade. So if I go here first. So this is your solar gain, solar south, 34 degrees. And for the greenhouse, the radiation is there. Then you have your the door in the inner facade. It allows the cold air to enter. And as it reaches the greenhouse, it gets warm. And then it again goes inside and it creates a whole convection.
Yes. Yes.
And for the trombe wall system, outside is the double glazing. Then the black you see is the cement brick wall, which is painted black, so that you have better absorption of the heat. And that wall gets heated and slowly it starts radiating the heat inside the rooms. And and the gap between the two, the DGU and the inner wall, it helps again with the convection. It heats the air inside. And then it goes, like when you open the window, again the hot air rises, and then you have the whole convection happening. So in the trombe wall is through conduction and convection.
Got it.
And and the so these buildings, so when we were at SECMOL, so these were the techniques which we learned hands-on with working with Sonam Wangchuk and experimenting with buildings over there. And then now we have started our own practice. So we incorporate in our designs with better plannings of buildings, architecture detailing that ways.
That's nice.
Yeah. And the good part is, like with the system, we are able to achieve plus 12 to plus 15 degrees, even when outside temperature is minus 20 in the winters.
Yes.
And there is no freezing of waters. So we don't use even a heat coil in the piping system. Just the construction technology and the method helps the client to maintain livable conditions inside the bedroom, inside the house.
Okay.
Yeah. Otherwise, in Ladakh, you have to burn certain amount of fuel to maintain the heat, and you have to drain the pipes because it will burst if it freezes. So passive solar buildings in Ladakh is really functional because also the, like out of the 365 days, I think only maybe 20 days in the year, maybe you'll have a gray sky. Otherwise, you have really good sun here.
Yes. Yes.
So yeah, that's how. Yeah, so I think Thinla's home, and then we are doing a couple of more projects where we have passive solar in different ways. Like it depends upon the client how much he's looking for comfortable conditions during winter, or whether they're going to really spend time in the winters. And then you decide upon the kind of like construction technique you need to choose.
Got it. Yeah.
If you have any questions regarding, like, so one thing is like green buildings in cities and green buildings here is completely different.
Yes, it's
Like
a different ball game when you construct in the cities.
We don't have much of a catalog or a company. We try to source the energy materials from whatever we get. We try to work with that, whatever is locally sourced.
Right.
Yeah.
Okay. And is there any other special kind of mechanisms or systems like this trombe wall that people who practice in the cities or in normal, places who are unaware of? If you can mention one or two.
Like used here?
Yes. Yes. It's which is very unique to, building in the terrains or in the hills.
I think storm wall is basically in Ladakh because you have such a good solar radiation and all. But unique to the hills is, like, I think the stone masonries, kind of through stones you do. Like I think in cities more it's like a cladding You'll
Yes,
have a
right,
cement base and then the stones will be
right,
cladded. Here we'll have through and through walls,
right.
you know, that ways. Using in Ladakh, one of the very good aspect is we don't have much of a termites.
No, my.
Yeah, so we here softwood works fine, like wood, pine wood, fir wood. Like in
Hmm.
cities and all, you'll go for teak wood or hardwood.
Correct, correct. Yes.
One aspect is good. Then we can still do an earthen roof here
Hmm.
because in few years the rains have increased, but with proper slopes and certain additional waterproofing membrane, we can still work with the earthen roofs. And
Yeah.
because the solar leakage for especially in places like here through roof is the most, because
Oh,
all your hot
okay.
air rises and
Rises up. Yeah.
the roof has to be super insulative. So it's not only the three walls, the roof, and we also berm the foundations. So that's why we have earthen roofs with some sawdust or insulative material really works well.
Okay.
Yeah. So those are the aspects working in terrain here, and we get really good quality clay for plasters. Yeah.
And what about lime plaster finish? You guys use that or no? You don't?
Yeah, we do use that, but lime we source from Jammu because here there are no kilns.
Okay.
Yeah, so in Ladakh there are no red bricks because maintaining the kilns or getting so much of wood to burn and all, I think that's a very energy intensive procedure. So just sun dried bricks and works fine. We do use a lot of lime plasters, but it's only at a certain clients who really want it. Otherwise, earthen plasters also work well.
Great.
Yeah.
Kaarinka, you have any interesting doubts or clarifications that you would like to ask with Faiza on the?
I am very amazed by how she's utilizing two kinds of windows on the southern side and utilizing or getting as much solar ingress as possible, specifically for a location like Ladakh. Very impressive work, ma'am.
Thank you.
Great. So thank you so much, Architect Faiza, for your insightful presentation on energy efficiency systems in construction. And this brings us to the end of the webinar today. Your expertise and the examples of your innovative projects were truly inspiring. Same with you, Ms. Kaarinka. Thank you so much for joining us today from Saint-Gobain office. We appreciate the time and the effort you both have dedicated to sharing your knowledge with us. Your insights have provided us with a deeper understanding of how thoughtful design can enhance our daily lives and environments. On behalf of all of us at Glass Academy and Ethos Empowers, we deeply appreciate your valuable time and thank you so much for joining us today.
Thank you so much, Shruti, for inviting